So now we're going to look at solving equations. So what is the difference between an equation and an expression? Now the main difference is if I have an expression like 2x plus 3, what makes this an equation is when I put this equal sign and I set it equal to some other value. Now this value could be just a constant or it could be another expression. Either way, this equal sign here is what separates the difference between an equation and an expression. So inverse operations are operations that undo one another. So if I add something to both sides, to undo that, I subtract something from both sides. If I multiply each side by something, to undo that, I am going to divide each side by that same thing. Now we will also be learning later on in the course other inverse operations, but these are the ones we're going to deal with right now. Now when I'm talking about solutions to an equation, I'm talking about the values that make this equation a true statement. So all values of the variable that I can plug in that give me a true statement. So if I plug in, if I have 2x equals 10 and I plug in 5, I end up with 10 equals 10. So 10 equals 10 is obviously a true statement. So 5 is a solution to that equation. In order to find this solution, we just isolate the variable by using our inverse operations. So solving one-step equations means I only have to do one inverse operation to isolate my variable. So for this first problem here, 12 times b equals 18. Since I have multiplication going on here, in order to undo this operation, the inverse operation is division. So I'm going to divide each side by 12, and that isolates my variable. And I get 18 over 12. Now, of course, we always simplify, so reducing that down, I get 3/2. So b is 3/2, and I can always go back and check my answer, which you should, and if you plug that in, you will see that it makes a true statement. So for b, 22 plus r equals 36. I have addition going on right here, so in order to undo that addition, I'm going to take away or subtract 22 from each side. So r is going to equal 14, and you can plug that in and see that it makes a true statement also. For c, I have division going on, so the inverse operation of division is multiplication. So I'm going to multiply each side by something. In order to isolate the x, I'm going to multiply by the reciprocal. So the reciprocal of negative 1/3 is negative 3, so I'm going to multiply each side by negative 3. Negative because I want to get rid of that negative. So x equals negative 81. And if you plug in negative 81, you will see that that gives me a true statement. For d, I have subtraction going on, so the inverse operation there will be addition. So I'm going to be adding 15 to each side. So w equals 23.2. And if I plug that in, again, I would see that it makes a true statement. Alright, so multi-step equations means I have to do multiple things in order to get to my final solution. So here, I have to distribute first. So I want to go ahead and distribute everything and make sure you always get that second term. That's the term that we always forget. Here, I have to be careful. I need to distribute a negative 2, not just a 2, but a negative 2. Now that everything is distributed, I'm just going to combine like terms on the same side of the equal sign. So combining like terms there. I see this guy and this guy match up. Well, 6x minus 6x, well, that's going to just give me 0. These guys match up, so negative 3 minus 8 give me negative 11 equals 11x. And now I need to isolate the x, so in order to do that, I need to undo this multiplication here by using division. Those will divide out and leave me with 1x, and I just get x equals negative 1. And you can go ahead and, of course, check your answer and show that that is a true statement. Alright, so 2 planes left the airport at noon. One flew east and the other flew west at twice the speed. After 3 hours, the planes were 2,700 miles apart. How fast was each of the planes flying? So there's a very simple formula that we have to use that hopefully we know, which is distance equals the rate times the time. So I want to talk about the distance for both. Now both of them have the same distance. They went 2,700 miles. So that means my distance will be the same. Now I have to consider the rate for both planes. Well, plane number 1 that went east has a rate of r, and plane 2 that went west has a rate that's 2 times that, so that's 2r. Now, do I know time? Well, it says that they traveled for 3 hours, so time is going to be the same for both. So my combined distance is going to be equal to my combined rate times time. So that's going to be r times my time, which is 3 hours, plus 2r, because that's the rate of the other plane, times 3 hours. So reducing that down. Now I just need to combine like terms on the right-hand side here and solve for my rate. So my rate is going to be 300 miles per hour for the plane that was going east. Now the plane that was going west, it was 2 times that, so 2 times r, so that's going to be 600 miles per hour for the west heading plane. So when we're talking about the solutions to an equation, we can say, is this solution always, sometimes, or never true? Now, always solutions give me answers that look like this. So if I get 10 equals 10 once I isolate my variable, or 0 equals 0, these statements are always true. So I know that I can plug in any value for my variable and I will get a true statement. Sometimes solutions are when you solve for your variable and you actually get your variable isolated down to just one number. That means that only that particular number is a solution, so it's sometimes true when my solution is just that value. Never is whenever I get a statement that is not true at all. So I go to isolate my variable and I get something like this. 1 equals -7. Well, 1 is never equal to -7, so that means there are no solutions and that is never true. So this is one solution, no solution, or infinitely many solutions. Or sometimes we say all real numbers as our solution. So let's go ahead and solve this equation and see if it's always, sometimes, or never true. So I need to first combine like terms on the same side of the equal sign. So 11 minus 7 is going to be 4. Combining like terms on the right-hand side, the 6x and the -3x, I get 3x. Now I'm going to do my inverse operations to isolate my variables. And you can see that the 3x's are going to sum to 0 on both sides. So I get 4 equals 5. Now when does 4 equal 5? Never. So that means this is never true. And if I asked you what the solution was, you would say no solution. So we're going to be looking at some literal equations. Now literal equations usually have more than one variable, and they are usually some type of formula that we use in actual practice. So here I have the formula for a volume of a cylinder, and I want to put it in terms of R. So hopefully you understand what this is saying. Put it in terms of R just means solve for R. So I'm going to isolate R. So I want everything that's connected to the R to go away. So I'm going to treat everything else like it is just a number. So I have a pi and I have an h, and I need to get rid of them. Right now they're multiplied, so I'm going to divide them out on both sides. And I'm left with volume over pi times height is equal to R squared. So I still need to isolate the R. Right now it's squared. How do I undo squaring something where I'm going to take the square root? So my R is going to be the square root of the volume over pi times h. So that is that equation in terms of r. Now, is this always, sometimes, or never true? Well, hopefully it's always true because it's the formula for the volume of a cylinder. But be careful here because I can only have values of the volume and the height that are going to be positive, which makes sense. I can't have negative volume or negative height. So this should always be true for values of the volume and height that are positive. All right, so it's your turn to try. Go ahead and put these problems as well as the work in your notes.